So if you'd like to create your own truss design, you can use one that's existing, and I'll show you that a little bit later in this video. But if you go to start a brand new family and then scroll down in this Imperial folder, and you'll find here a template that you can use for structural trusses. The difference is that in this family, they're showing the reference planes and the dimensions, so you can create your own reference lines and planes if you need to as you're creating your truss, or you can open up an existing one and turn on the visibility graphics to see here those reference planes. So in this one, it's already set up for you. You can save it as a different name so that you know that it's your individual truss name. I'll just call it my truss design. And now you can change the truss length here. Maybe I'd like it to be 40 feet. And the height. In the Create tab, you have the top chord, the web, and the bottom chord. So for the top chord, I'm going to draw here a line that goes across the top and create the bottom chord here. Now this is where when we're establishing the web members, we need to draw additional reference planes so that we can align them and lock them to those different planes. So I'm going to click reference plane and I'll put one here. And one here. Just a quick example of creating your own design. You can go to create and click web and start to draw individual lines. Each one is an individual line, so you have to click and then click, click, click to create this unique truss. I know there would probably be more members than this. And then use the Align tool to align the reference plane with that individual member. So click on Align, click the reference plane, click the web member, and then lock it. And what that does is it assures that when you're in the drawing, it's going to lock in place and not be skewed to something else that you weren't expecting. So I'm going to go ahead and lock all of these web members to those reference planes, and also the top chord and the bottom chord. Align it and lock it. I'm ready to save it and load it into my project. And once I load it into my project, it will be the first one that'll be in the properties dropdown. I can then go ahead and click, pull my mouse across here, decide on where I want to put that truss, and there's my design. Now, if it was already loaded and you needed to place it, you go to the structural tab and you click on truss right here, and then you have this list of trusses. You may not have loaded any trusses yet, so by doing that, you can pick load family and go down here in the US Imperial folder to the trusses. But there are all these other connections where you can find your gusset plates and some of your stiffeners that go in the web to make that the beam stronger, and columns and different foundation pieces that you would need for your design. So here we want to go to structural trusses. There are several here to choose from that you can actually open and modify. So I'll just come ahead and and grab this this truss that's here, a 12 panel truss. And when I place this truss, you'll see that the members are kind of big, depending on your design. So you can still click on the truss, come over to here, Edit Type, and inside the Edit Type dialog box, you can change the structural framing type here to something different, whatever you have loaded. So I could go back and load angles and different structural framing pieces that I can use for the top chord and the bottom chord. Even lumber when we're talking about our wood trusses. If you've already placed a truss, whether it's one that you've designed or one that was with Revit, you can pick Edit Type and then duplicate it and give it its own name based on your truss design. Like this next one will be made with wood members. So I made it my truss design wood. And now the structural framing type can be any kind of wood, be it timber or 2x construction. And these need to be loaded from all of those structural members that you can load. And so I'm changing the top chord, the bottom chord, and the web members. And when I pick OK and place this truss, I've got a new style that I've created with different framing members. And it's very customizable. Under the Insert tab, I'm going to load more families so that I can pick up a gusset plate. I'll go to Structural Connections and Steel. And there are several gusset plates here that are basically the form itself. You can customize these also, but once you've placed them, you can change the size. So you have to place them under Components. So you'll go to Component and place the component, and you'll see that gusset plate that you loaded. And now in the ribbon, you'll see that it's Place on Face. So I have to kind of adjust it so that it's placing the gusset on the face of this bottom chord or top chord. The top chord's a little trickier because you have to orbit to get that face. You can hold your shift key down and the wheel of your mouse to orbit, in case you didn't know that. But here I can select the gusset plate, and in Properties I can change the length and the height and the thickness of that individual gusset plate. You can also tab to select individual members. Then in Properties you can see the Start Join Cutbacks, and if I change that to something like 3, then I can cut back that individual member 3 inches. If you try to grab the grips and drag them across to make them shorter or longer, then the member will skew because it takes it off its axis. And there are so many different structural designs that we can create in either changing out members or customizing families so that those members are different sizes and shapes. So in this example here, to save time on the video, I've changed by going into Edit Type that style to a smaller member for the webs than the top chord and the bottom chord. And then I rotated also in this dialog box. By picking User Defined, I can change the angle of the members so that it makes more sense for them to tie into the gusset plates. And so in this design, I added the gusset plate and I extended this member by tabbing to select it, unpinning it with this small pin, and then changing here start join cut back to a -1 foot, and also changed the location of this gusset plate by dragging it to a different surface. So if you need to move this gusset plate away from the face, then you can select it and pick the move tool, but make sure that you take the check mark out of constrain and put a check mark in disjoin. That way you'll have flexibility in moving it to the surface that you need. The properties that are showing are the ones that are individual for that element that you have selected. Under Edit Type, you have a different set of properties that are specific to that type and not the instance, which is based on an individual setting in properties. So as you can see, truss design can be very flexible. I selected this one that came with Revit and I picked Edit Type and duplicated it to create my own truss that has the double angle for the top and bottom chords and these round bars for the individual webs. As you know, several trusses are connected in different ways. So in some cases, the top chord then will rest on a steel member, or in other cases, the steel beam will rest on the bottom flange. So in all of these different situations, you have different connections and heights for your trusses and your beams. So back in the Revit file, when you have different heights, when you place some of these trusses, they will be placed in according to their bearing, like this truss here will be placed on the top of the wall, whereas a truss like this one will be placed 6 feet below. You may have to go to the 3D view, select that truss, and change the start level offset and the end level offset to what your needs are. And as you can see, you will also have to change the top chord member so that it extends more than this design, and maybe the bottom chord also, because it ties in with an angle, or it ties into not only this wall but also a structural steel framing system. I would like to point out to you though, if you are using this truss and it's sitting by its top chords, you may not see it in the plan view. When you place your truss, the first thing you should look at is where the placement plane is. So I'm going to click on truss and then look here at the placement plane. When you have trusses that are below the surface of the wall, you may not be able to see them here in the floor plan view. Sometimes we can use underlay to see the objects below that level, but in this case we have to use in properties the view range. Scroll down and click on view range edit, and in this view range you have a top and a bottom as your primary range and your cut plane. In order to see the structural framing member in this level, we'll need to change the bottom of this view range. The view depth can't be higher than the bottom of the view range, so I'll make both of these a -8, and I'll pick apply, and then I'll be able to see that member. If you see other things that you don't want to see in your drawing, you can change the view range and the cut plane to what your display would be for this view. I also wanted to point out to you that we do have in the reinforcement panel rebar that we can place within a wall structure. So if you have a poured concrete wall, we can create here a path of reinforcement bars in that wall. So for your bond beam, across the top where these are bearing on that wall, you would want some reinforcement there. Or in a concrete floor slab, you can create a path or an area, and that area can be filled with the welded wire fabric mesh that would be a part of the structural system for that concrete slab. In case you're wondering how I got this wall to be transparent, under the visual styles, you can pick graphic display options and you can change the transparency here. Once you do that, you won't have access to the shadows. Okay, so in the level 2 plan, I'm going to create a grid structure. In the architecture or structure tab, we can go to grid, and then I'm going to just pick a point, pull my mouse up and pick here. I'm just creating a grid that I can show you here, some of the structural features that are in Revit. And if I go to annotate and place this dimension and then choose here this equal, it will space them out equally, and I can even lock those dimensions if I like to keep them in place. And here, same thing. I'm going to lock this dimension. And now place my columns. And in the structural tab, the column is a structural column. In the architecture tab, you have both architecture and structural. So I'll use the structural column, and you can change here the size of your column based on which ones you have loaded. I'm not going to worry too much about the size right now. You know that you can load different sizes and make these appropriate to that scale. But the important thing here is to take a look at the options bar and see that we're on level 2, but the depth is going to go to level 1. So when you place columns, you have to think about where you want to start the column, and do you want to go up or down? Do you want to change this to depth or height? So the depth from level 2 will be to level 1. If you want to place a column that's unconnected, then you'll have the option to decide on the height, but if you place depth, then it's 9 feet down. So I'm going to go ahead and place these columns with the depth of to the level 1 since I'm in the level 2. And before you place it, you can use your space bar to rotate them if you like. And then you have a choice of just clicking here on each one of these columns, grid, or you can pick at columns, and then you're in kind of a sketch mode. You can cross over all of these column grid lines, and you'll see the little columns there. If you had any more to pick, you could hold your control key down and continue selecting grid lines to place those columns at the grid. I'm going to go ahead and pick finish, and there are our columns. When we place beams, it's the same kind of idea. We have to make sure that we are placing them on the right level. But since I have this grid, I'm going to go ahead and pick on grids. Otherwise, we would have to click for the start point of the beam and the end point of the beam. So I'll go ahead and pick on grid lines. And in the same way, we can change our beams, if that's what they are, to a different size, and click here on that line between the two columns. Holding my control key down, I can click on each one individually to place these beams, and then pick the check mark finish. And there they are. We can also use this tool called Beam System. The Beam System is sort of like sketching a floor system or a floor extents, and the beams will be created automatically. So if you want to use automatic beam system, you can change the spacing here between the beams, and then once you're in the plan, if you get close to the structural framing member that you want to use as a guide to the direction that you want them to span, I can click here and know that my beams, because the beam type is still a wide flange, will be placed here between the girder beams. We can also pick sketch beam system, and by doing that I can sketch here a rectangle or lines like you would sketch a floor extents, and change the beam direction if I needed to by just clicking here beam direction and clicking one of the end members. Here I might want to change my beam type to bar joist, and when I pick the green check mark, I'll see that the beam system is in place. And by using it, we did pick up here the tags. If you need to tag the rest of these members, you can go to the Annotate tab and pick Tag by Category. And then in the Options bar, you can take out the check mark with Leader, unless you want that here, and then click on one of your framing members to tag that member. Or tag all if you'd like to tag all of your structural framing, and whether you want it in a box or standard. If you need to create a detail, there are angles with bolts that will show you the connection between these two. And we also have in the Modify tab this option to cope the beam or cut out this beam flange so that just the web is attached web to web. On a roof design, we need to raise the column and or the beam itself so that we can slope it. And if you select the column, you have here the top offset, which you could change if you'd like to, depending on the span, set that column up a little higher. And if you want to select here the structural framing member, this wide flange, you can do the same thing by changing the start level offset to something else so that you can raise those members so that you get that kind of slope from one side to another. Okay, this is the beginning of understanding some structural framing tools that are in the Structure tab under the Structure panel and the Reinforcement panel. We've already looked at foundations, but you can see that you have here the foundation wall and the slabs that you can create, even the floor slab edge, which you can customize the profile of and create a different slab edge. We also have a brace that we can place a structural bracing member, and when you do this, you want to check your reference level, which we're on level 2, your start and your end. So my start can be 2, there's a end level that's going to be 2, and then in my plan, when I click from one beam to another, you'll see it in the 3D, but you won't see it in the plan view. See over here, you can see it in the 3D view. The reason you won't see it in the plan view is that in properties, we need to change our detail level from coarse to medium or fine. Because it's coarse, we're only seeing the main members, and they're only in lines, represented in lines as we would normally want them to be. If we want to see the bracing members, we can set it to medium and pick apply, and then you'll be able to see that brace, but you'll also be able to see here the top flange of the beam with a dashed line representing the web and the angle in a little bit more detail. So it depends on what you want to see in your plan view. If I go back to course, then I'll only see that bracing member in the 3D view. We have openings in both the architectural and the structural tab, and in the structural tab we have one called by face. And if you click on it, you can read down here at the bottom left corner sometimes little notes that tell you what to do. And so we're clicking on a face that's perpendicular to the face that we want to draw on. So as you pull your mouse here close to the beam, you can use the tab key to tab so that you're not clicking on the face that you want to cut a shape out of, but you want to select the opposite or perpendicular face. And now when I draw a circle or whatever the opening is, it will create that opening right on that web member. I can pick the green check mark, and now I have an opening here in that beam. Okay, if you have any questions, let me know. These are kind of the basics of creating a structural framing plan and working with trusses.